All right.
All right, thank you.
Well, thanks. Thanks, Justin. My name is Brian Thomas. I'm going to be talking trash to you guys tonight. But before I get started with that, I want to say thanks to Justin and Emily and the Applied AI group. I think I've really benefited from attending these meetings in the past. They're very educational, informative, and it's really benefited me. I wanted to give back to the community and share what I've done with AI. And hopefully this can educate and inspire some people in this group to think about this other ways you can apply AI. So, little background on me. I've worked as director of engineering for a few companies in the Twin Cities, leading global cross-functional engineering teams in multiple different industries. Mainly worked on medical devices. That's a huge industry in the Twin Cities. I've worked for a few different medical device companies. But I've worked on other industries too, like autonomous electric vehicles, like I'm going to talk about today, military systems and credit card machines. Some people talk about climbing the corporate ladder. I look at my career more like a jungle gym. You might want to go sideways once in a while and try a different industry. And I've learned different things in different industries. I've learned, about AI going into insurance, working for Optum, which is part of United Health Group, and did that about 8 years ago. And I learned about cybersecurity working on credit card machines. So I applied this AI stuff working on electric vehicles, working on garbage trucks. So it's kind of cool learning different things in different industries and then applying them in other industries. I've also started a couple startup companies. Back when the internet first became big, I created Internet Luxuries, your online store for fine home decor. And we were selling luxury home goods on the internet. And then later on, I created a smart pill box with a company called Clear Rock Technologies that had a camera in it that was monitoring the pills. So you could see if grandpa or grandma's compliant taking medications, and you can call them up if they're not and try to help them take their meds. Sold both those companies. I have degrees in business, electrical engineering, and computer science, certified in project management, cybersecurity, Lean Six Sigma, and have multiple US patents. Little disclaimer here, these views are my own. I'm not representing any company with this. And also some of the stuff I'm going to be talking about is very dangerous. So do not try some of these things at home. And I'll point out what later on in the presentation. But there is many different types of AI, and I've used different types of AI in my career. Starting about 8 years ago when I worked at Optum, we were working on chatbots back then. And, there's supervised and unsupervised learning, there's machine learning and deep learning. So when we were starting to do chatbots, we were using machine learning to try to discern the intent, what somebody was saying in a question to a chatbot. And then as we moved from machine learning to deep learning, we were able to help discern complex intent. So when somebody asked a basic question versus a rambling question, we could help try to use deep learning to really understand what they were asking and try to answer it. So NLP is natural language processing with chatbots. There's other forms of AI, computer vision. So your eyes can look at things and make intelligent decisions, just like you can have an intelligent conversation with your voice. So that's a different type of AI. And that's the one I'm mainly going to be talking about tonight. So there's a lot of stuff going on with generative AI and chatbots and chat GPT, and it's really cool, amazing, and fun, and I use it regularly, but that's not what I'm talking about. A different type of AI, computer vision AI, and combining IoT, which is the Internet of Things, so wireless control of things that are not computers. And so combining AI and IoT to create smart, connected products. So that's what I'm going to be talking about tonight. It's a different form of AI or applied AI. So this is, we're going to apply it to the refuse industry, and that's a huge industry worth about $80 billion annually. And America throws away around 300 million tons of trash every year. And I don't know if you guys have ever been to a landfill, but when I saw one for the first time, I'm like, wow. I mean, just huge mountain of trash and trucks dumping dump trucks full of trash onto the top pile, and big machines trying to move it around and push it around. It's like, it really incentivized me to try to be better at recycling after seeing that. We've made progress in recycling back in the 60s. You might return bottles or something. And back then it was like 6% of recycling was recycled. Now we're up to like 32%, but it varies state to state significantly. but still a majority of the trash still ends up in landfills. And so a couple other fun facts. There's electronics can be recycled, but it needs separate things. And usually there's a separate place to go drop your electronics off. So usually only 20% of electronics is really properly recycled. And a big contributor, surprising, is food waste. Food waste is a huge contributor to landfills. And actually some company or some municipalities, like the city I live in, the north side of town, just a few weeks ago, they started adding composting, a fourth type of trash. So I got trash can, recycling, yard waste, and now there's composting as a fourth type. So that is a huge contributor. Kind of surprising, but people throw a lot of food away in America. Just a couple other fun facts. Some companies are learning to reclaim the methane from decomposing waste to generate electricity and can power like 1 million homes with electricity annually. And then single stream recycling, having them sort things or just allowing people to throw everything together and the company sorts it out. There's been different studies on how compliant people are with that. So I went to go work for a company that's about an hour south of the Twin Cities that makes garbage trucks and cement mixers and other industrial trucks, not trucks that transport stuff, but trucks that do stuff, like a garbage truck. And they wanted me to connect them all to the cloud. And so they have 3 different product lines. And so this is going to be important later on in the presentation. There's a front loader that has 2 arms that will reach down and grab a commercial dumpster, like from a restaurant, and throw it over the front of the truck into the back of the truck. Okay. There's a side loader that has 1 arm that reaches off your curb, grabs a residential can and dumps it in the side of the truck. And there's a rear loader that has no electromechanical arm, but usually there's a second operator back there. Okay. And so we connected them all to the cloud. So we designed a telematics unit and put that in the truck, and that connects to the CAN bus of the truck. CAN is an acronym. It stands for Controller Area Network. And so all the control systems of the truck, all the electronics of the truck, all communicate with each other with this CAN bus, this Controller Area Network. And so we connected this telematics unit to the CAN bus so we could monitor everything the truck was doing. And then there's a cell modem in the telematics unit, which sends the information up to the cloud. So we monitor what's going on with the truck and make a cell phone call up to the cloud and transmit this data periodically up to the cloud. And from that, then we were able to create websites that would allow big companies like Waste Management and Republic and small companies, municipalities, to be able to manage a whole fleet of trucks, find out what's going on with them, and monitor them in real time to deliver performance, efficiency, and safety. So this is information going from the truck to the cloud to a website. Okay. Now, on the next slide, the Wi-Fi symbols are in the other direction now, if you noticed. Information can also flow down to the truck. Okay. So with Agile and DevOps, we were able to load new software in the cloud regularly. But then we were also able to take and load new firmware into the truck with over-the-air programming by sending it the other way through the cellular modem. Okay. And then we did this, we launched it with production-grade cybersecurity. So to do that, a lot of times when you have the cloud, you've got different environments in the cloud. You got a dev, test, stage, and production environment. Production is, production-grade cybersecurity. So we had a security certificate in the cloud for our production environment. And then to make it secure in the truck, we created a public-private key pair with cybersecurity. We kept the private key in our factory. We signed the software when we created a new version of firmware for the truck. We signed it to make sure that it was signed that it came from us. And then we'd send it over the air, and the truck would verify it with the public key and say, yes, this is software that's legit, that it came from the company and not some hacker. And then it would change the software in the truck. And so once we had this is a platform that enabled the use of AI. So we could quickly load new software in the cloud, load new software in the truck, and regularly we could update software multiple times a day if we wanted to try new things with AI on the truck. And once we had all this monitoring going on, I was kind of surprised to see that the telematics was showing that it's common for these big trucks to get low single digits in miles per gallon. The trucks, there's big, huge trucks and there's trash compactors inside and they're carrying a lot of weight and they don't get very good gas mileage. Okay. And so monitoring these trucks to figure out, is the fuel efficiency dropping and why is it dropping? Does it need to be tuned up? Are the tire pressure wrong? If the tire pressure's off by a little bit, that can affect the gas mileage. It can also affect the wear and tear on the tires, which is expensive. So trying to lower the total cost of ownership of a truck was one of our goals. And so being able to monitor all this stuff and optimize it could make a big difference in the profits of the company. Also, another thing that kind of surprised me is the telematics was showing that a lot of these trucks do 8, 9, 10, or 11-hour workdays. And that'll be important later on in the presentation. So with the telematics, you can also do route optimization. You can help them find the most optimal route. A driver might be sick one day and they might have to reroute trucks. And so with this, you can dynamically reroute the trucks. Another thing is backing up the trucks. There's not a lot of windows in these trucks and there's blind spots. And trucks can damage things when they're backing up. So we try to minimize the amount of times they back up. And we record every time they back up and we drop a pin on the map and we provide a report to management and the management can look and see, why is this driver backing up 10 times more than this guy? Does he need coaching on how to drive a truck like this? Or maybe it's legit because he's got a route that has a lot of cul-de-sacs on it. And the cul-de-sacs, if cars are parked out there and the garbage cans are out there and trying to get a truck in there and around and stuff like that, that might be a reason that's legit why they're backing up, but they try to minimize backing. Okay. So I was originally hired as director of advanced connectivity, which is just IoT, but we got the system up and running in just a few months and they were like, wow, we've been trying to get this working for years. And so they asked me if I could assume additional responsibility and be the director of advanced technology, which is AI and IoT. And be responsible for these kind of advanced technology areas, automation, electrification, active safety, sustainability, which is like friendly to the environment, and advanced connectivity, which is what I was originally doing. So assumed this additional responsibility. And one of the things we did is then we cameras around the truck. So we could monitor what the truck was seeing when it was driving. And we took pictures all day long. And then we sent these pictures over to our friends in India, which helped us label these pictures and put bounding boxes on the things to identify where the garbage cans were and, other things that might be on the curb, like a mailbox or a dog or something like that. And then we created an AI model and we trained it with all these pictures and we fine-tuned the model so that it could accurately identify what the garbage can looks like. And so originally we took like over 10,000 pictures of trash cans and we used 80% of those to train the model and then 20% of them to test our training to see how accurate it was. As time went on, we had more and more trucks with more and more cameras doing more and more routes. And we had more data. And after a while, we were using about 50% of the data to train it and 50% to test it. And then as we got pretty good at recognizing a garbage can in what I call blue sky scenario, there's other edge cases, as I call it, where things aren't perfect. There's cases where the cans are obstructed by a parked car. There's cans that are overfilled with trash. This hardly ever happens in Minnesota, doesn't it? Snow on the trash can. So being able to correctly understand all these involved taking a bunch more pictures, like 1 million pictures, so that we could find 10,000 pictures of these edge cases to be able to train a model to be able to detect that, to get it really good at detecting trash cans in all sorts of different scenarios, different lighting, different seasons. Okay, and then, so now we've trained the trash truck to be able to understand what a garbage can looks like. Now here's a problem with the side loader. When somebody's been doing it for a few months, they get pretty proficient at it, but for the first couple months, they're not very good at it. They got a joystick that they can control that arm with. And, you know, sometimes they are not very good at it and they try to extend the arm and they tip the can over. Oh crap, then you got a big mess of trash. You got to get out of the truck, clean up the trash. It's not fun. It's big productivity kill. You got that little shovel on the side to help scoop things up, but it's not fun when you tip it over. Okay, so, or another thing that might happen is maybe they go and they drive up to it and they extend the arm and, oh, I'm not aligned, pull it back, drive the truck up a little more, extend the arm, I'm almost there, pull it back. Okay, third time's a charm, I got it this time, let's dump it in, you know, but it's not as productive to do it that way, you know, but with this, with AI, you can detect where it is and whether you're perfectly lined up with it and stop perfectly the first time. Okay, and then we use LiDAR, which is like radar, but with laser beams. And that allows us to detect how far away the trash can is. And so that we could extend the arm perfectly. We can stop perfectly with it aligned. We can extend it perfectly, grab the trash can, dump it in, set it down precisely where we found it. Okay. Now, like see here where it's this can is backed up against the curb. If you kind of pushed it, if you weren't lined up, you could see how you could easily tip that over. One thing, you know, trying to put it back where you found it. I'm going to show you a video in a little bit that shows this. And the first part of the video is the old system. And then the second part of the video is the new system. Okay. So here is we put it on a waste management truck and see how the customer had their trash can sitting on the curb, but he left it in the street, you know, he didn't put it back where he found it. Here he's pulling up, but he's not lined up right away. So he extends the arm, but he's got to actually drive the truck forward before it's lined up, before he can grab it. And then he puts it back, but he doesn't set it on the street or the curb. He sets it kind of hanging off the curb where it's kind of dangling and wobbling a little bit, you know, so it's not the best thing. And here he's kind of trying to line up, but he's not perfectly lined up. Now here's a new system with it updated. He pulls up perfectly, grabs it on the first try. And it was sitting on the driveway and he doesn't leave it dangling off the curb. He goes and puts it back where he found it, right on the curb. So it may seem subtle, but these things add up. If you do it over and over all day long and save a few seconds for every hand, that can add up to a productivity improvement. Now, this is one where the trash can was overloaded, but it was able to detect the can even with it overloaded and then go put it back on the curb instead of the street or dangling off there. So that's one use of AI. And another one, this is a combination of AI and IoT. So with recycling, this is the mixed recycling that I was talking about, where you can mix multiple different types of plastics and cans together in there. And with AI, you can real time go in and look at the trash and see what we call contaminants. If there's something they put in the recycling that's not there, it's contaminated, we call it a contaminant. And then that causes all sorts of problems for the company that's trying to recycle things, okay? And so with real-time detection of the contaminants in there, and with IoT, we can then send a message to the customer and let them know that they're putting contaminants in the recycling, and or we could send them a bill. In fact, that happened to me. You know, I created this system and I got the benefit from it. Okay, so you can put things. So I bought a TV like this. Okay, and if you ever buy a TV like this, it comes in a cardboard box with styrofoam packing, and both the cardboard has a recycling symbol and the styrofoam has one. And so I threw that all in the recycling. And they took the cardboard and not the styrofoam. My recycling company doesn't want styrofoam for whatever reason, even though it has a recycle symbol on it. I think there's static electricity and other hassles with it or whatever. They just don't want it. And they gave me a $10 fine, which actually was enough for me to tell other people about it, but not enough to piss me off to go to a different company. But anyway, so that's one thing. You could put an optional message or an optional bill, and that's kind of what I recommended, is put it low enough so that it catches their attention, but not high enough so that it causes them to switch company. So another thing you can do with AI is look for a distracted driver. things like you could be eating or drinking while you're driving, you could be smoking or texting while you're driving, or falling asleep while you're driving, and AI can detect these conditions. And you have the option to give real-time feedback to the driver, like, hey, you should go get a cup of coffee, I think you're getting sleepy. Or you could give a report to management, or both, and then management can decide if they want to coach the driver or not, based on what they see. So that's one type of distracted driver, AI. That's where the garbage truck driver is distracted. Now, there could be another driver that's distracted. These trucks tend to start and stop a lot, and a lot of people are driving and texting on their phone at the same time. And it has been known that sometimes people, unfortunately, rear end garbage trucks. And that's important when I talk about product lines. For the third product line, where there's a rear loader, or there's a second operator back there, which we care about and don't want anything bad to happen to him. So you can use AI to look at cars that are coming up from behind you and try to discern, does this car look like it's going to slow down and stop? Or does it look like it's going to drive around us? Or is it on a collision course for us? And with AI and with IoT, we can put wireless electronics in the safety vest of the operator to alert them with light, sounds, and tactile feedback to notify them that they might want to get out of the way, that there's a rear approaching car that's concerning. And so we can alert the operator to get out of the way. Now, here is a situation where it's time critical. If it's safety critical, every fraction of a second counts in this instance, okay? So a lot of times when people do AI, they send the software up to the cloud for training and to execute. And you can do that. It's cheaper. There's usually computing power in the cloud is cheaper than doing it down here. But the problem with that is it might take a fraction of a second or a couple seconds to go up to the cloud and back, and you might not have that much time if it's a safety critical condition. So we used what we call edge architecture. So we had GPUs in the truck. We had an NVIDIA GPU doing real-time processing of the camera feed that's coming, cars coming from behind. So our edge architecture and real-time processing to make sure that we shaved every split second off that to notify the operator in time to get out of the way of somebody that's distracted driving. All right, here's some more industry fun facts. There's almost 500,000 people in America that do refuse management and recycling. And there's a challenge that I had one of the top waste management companies in America tell me that 40% of their drivers are going to retire in the next 5 years. There's a lot of baby boomers that are getting ready to retire, and they're already struggling to recruit people to be garbage truck drivers. It's a dirty, smelly, dangerous job. In fact, when I was doing research on this, it said it was more dangerous to be a garbage truck driver than it was to be a policeman. Okay. And so they're struggling to recruit people, and a bunch of people are going to retire. So they were interested in investing in autonomous driving garbage trucks. So we partnered with a couple major companies to help develop autonomous driving. Other things that were factors going on is we were developing this during the pandemic. And during the pandemic, there was worldwide supply chain issues. Okay. And so a lot of companies had record backlogs of trucks that they couldn't ship and couldn't deliver and couldn't claim revenue for because they were missing a few parts. So we had this issue of buildup of a lot of trucks that were 95% built, but we couldn't sell and couldn't collect money for. And so we decided that as the advanced technology group to develop a new truck with parts we could get, and decided to convert from, this is a diesel chassis on the left, and on the right, I guess I learned this term when I was a kid. I used to ride a skateboard around. I was kind of surprised they call this a skateboard now. They don't have the axle and the differential and stuff, if you're familiar with auto mechanics of a traditional car or truck. They put the batteries in the frame, and it's kind of a more low profile thing that they build the frame on. If you remember cars of yesterday, they have a big hump in the middle where the axle was going down. You don't need that anymore. There is no axle going down, and there is no internal combustion engine in the front anymore. And so it's all just low profile now, and they call it a skateboard instead of a chassis. And so they have this e-axle system and a smart battery system. E-axle means that there's motors at the wheels, not a big engine in the front of the car. So we designed and built a cool new truck, an electric truck with IoT and AI. And so part of my job was electrification. So we had to replace dirty, noisy diesel engines with quiet, clean electric motors. And so, as I talked about earlier, we designed it to have an 8-hour shift with adequate margin to get back. And then I found out a lot of the trucks were doing 8, 9, 10, 11-hour days. And oops, well, I guess we have to design it better so that it lasts longer and has more range. But if people are familiar with entrepreneurship and designing new things, there's a concept called MVP, which stands for minimally viable product. What's the minimum functionality where somebody's willing to buy it? And then you can keep working on it, fixing it, add more features and improving it, and sell it to more people. And at the time, Republic Services said, we'll take 50 of them. And they're expensive trucks. And so they placed an order for 50 trucks in 2023 while we worked on trying to improve the range and improve the efficiency. And they liked it so much, they bought another 100 trucks in 2024. And other companies have been buying them too. So the truck, I believe, was a success. And earlier I talked about that public service announcement about danger. So if you guys ever work on an electric vehicle or an electric truck, these big fat orange wires have really high voltage. So don't touch them unless you really know what you're doing. And also, if you see a pair of orange wires, that usually means it's high voltage DC, which comes from the battery, hundreds of volts DC. And then those two wires go to a component called an inverter. And the inverter will convert it from high voltage DC to 3-phase AC. So on the output, you'll see 3 wires coming and going to each of the wheels. So you see routing back here, there's triplets of orange wires. So that is high voltage 3-phase AC that goes to the motors that are attached to the wheels that drive the wheels. So that's the don't do it at home unless you know what you're doing thing. Okay, so when I started developing an autonomous vehicle, I did research on it. And my typical mode of operation of developing a system is I start with customer requirements and then turn those customer requirements into system engineering requirements. And then I create some system architecture and design. And then I work on the subsystems like software, hardware, firmware, electrical, mechanical. But when I did research on autonomous vehicles, what I was advised to do is the first thing you have to do is ODD, the operational design domain. Okay. And that is trying to define under what conditions do we believe this vehicle can operate safely and autonomously. And so we spent a couple days just brainstorming things that you and I take for granted when we drive a car. You know, how to drive, you know, can this vehicle drive in the daytime and nighttime? Can it drive in sunny weather and rainy and snow and ice? Can it drive in a school zone? Does it know how to handle a construction zone? You know, you and I just don't even think about that. Oh, there's cones in the construction zone, you know, and you know how to slalom around it, you know. Well, do we know how to handle that autonomously? And so we had to think about this. And we created like 300 conditions that you and I just don't even think about when we drive, but you really have to think about if you're going to design an autonomous vehicle. So what is the domain that you can operate in safely? So that's the ODD, okay? And so also, since this is a safety critical system, and since I do have a background working on medical devices, another thing that I like to do is after you do the first pass at your system requirements and system architecture and design, I do a failure modes effects analysis and try to figure out what could possibly go wrong. And that's a practice that we always do in medical devices, especially class 3 medical devices, which are the most safety critical. And that helps you then take, okay, here's what could go wrong. So how do we then mitigate those things that could go wrong? And so then you go back to system requirements and you add additional requirements to mitigate the probability and or the severity or both of things that could go wrong to create a more safe system. So you add additional requirements, additional architecture, and then after I've done that first pass through that loop there, then we start working on the subsystems and the software, and we start iterating quickly with Agile and DevOps and creating software after that. But we have a framework that is safe up front for autonomous driving. So a few more things about ODD. Why do we do this? The number one reason is for safety. So by clearly defining ODD, manufacturers can ensure the vehicle only operates in conditions where it can handle it safely. And for regulation, for regulators and compliance, it provides a framework for regulators to evaluate and to certify this vehicle as safe, autonomous vehicle. And it helps the engineers that are doing system design and system testing to use ODD to guide the development and the testing and the validation of this autonomous driving vehicle. And it also helps with user trust, so that clearly communicating ODD and the boundaries of where we think this can drive safely lets people understand where and when the vehicle can drive safely and autonomously. So the Society of Automotive Engineers has defined 6 different levels of driving autonomy. And the first 3 that are in blue are where the human is driving. And the last 3 that are in green, the car is considered driving, although with category 3, which is what we were striving for, is the vehicle is really driving, but if it tells you, you need to take over, you must drive, okay? So you have to be sitting there and ready to take over driving if the car says take over, okay? Level 4, it's not going to require you to take over, but it can't handle all conditions. And level 5 is something where it won't require you to take over, but and it should handle all different driving conditions. Some of the difference between level 0, 1, and 2 is there might be driver assist things. They call it ADAS, advanced driver assist systems, like lane departure warning and blind spot monitoring. These are things that are kind of precursors to self-driving vehicles that help you drive safer, but that's just kind of the different levels of autonomous driving. So the solution. So to do this, we put a whole autonomy kit all over the truck, which has all sorts of different sensors. And some sensors are better or worse at different things. They do different things. And I'll talk more about the sensors on the next slide, but there's a variety of sensors that detect different things that are close and near and far and help you in different driving conditions or park and stuff like that. And then all that sensor information is fed into your AI algorithm, and the output of that is used to control the steering wheel, the brake, the accelerator, and the turn signals. Okay, and there's a term called a drive-by-wire kit. And so you can put a drive-by-wire kit on your steering wheel. And so you can overpower the drive-by-wire kit by grabbing the steering wheel and driving it yourself. But if you have your hands off the wheel, the car can control the steering wheel autonomously for you, and the gas and the brake and the turn signals. So there's a bunch of sensors that you put on the car. There's ultrasound, GPS, for navigation, gyros and accelerometers for orientation and motion tracking, LiDAR, which is like radar, but with laser beams. Radar is better for long distance, cameras, and there's pros and cons or strengths and weaknesses of each of these different types of sensors. Some of them work better in different types of weather condition, better or worse. And some of them are, long distance or short distance things. And so there's a combination of different sensors and we did something called sensor fusion. So we try to take all this information and combine it and look at the task that we're trying to do and take the best information that we have, the sensors, and try to ignore the rest of the information to make the best possible decisions on autonomous driving. And then there's testing the vehicles. So we had this course that was designed to look like a city, but it was a closed course. It wasn't really a city. We could drive this vehicle around that. But there's also some states in America are more friendly or more risk averse or more risk tolerant to driving autonomous vehicles. So every state has different laws. And so some states were more friendly for us to test our vehicle in. So states like Nevada, which has a lot of deserts, they were more friendly. And that was one of the first places we wanted to test this, in Nevada. Texas, there's other states that are more friendly, and other states are more risk averse with self-driving vehicles. So we looked at testing it in a 3-phase approach. Okay. The first phase is a safety driver. The guy's got his hands ready to grab the wheel and watching what the autonomy does, but it can grab the wheel and override it if it's not doing the right thing. The next phase is a leader-follower configuration. So a lot of people have more than one trash bin outside. I have 3. I've got trash and recycling and yard waste. And now my city's coming up with a composting thing too. So it's very reasonable to assume that you could drive 2 trucks down the road at the same time, and one picks up the trash and one picks up the recycling. And you could have a leader-follower configuration where there's one driver and 2 trucks. And the driver's in the truck in the back, so he's watching what his own truck's doing, and he's also watching the truck right in front of him. And he has the ability to kill and stop the truck in front of him if it's not doing what he thinks it should be doing. Okay. And then the third phase is we call teleoperation, where there's no driver in the truck. Okay. And the truck can drive by itself. And then if it gets to the point where ODD kicks in and it says, I don't know if I can handle this situation, then the truck will pull itself over and park. And then it'll call back to headquarters and say, I don't know how to handle this situation. And somebody back at headquarters could turn on all the cameras and look to see what's going on and say, oh, I guess there's just a plastic bag floating in the road. Don't worry about that. You can drive through that. Or no, there's a major construction zone. The road's all torn up. You better turn around and come back. So these are kind of 3 phases of testing it, where you're giving more and more trust and more confidence in your autonomous driving. Another thing is we talked about cul-de-sacs can be challenging. So we wanted to design the truck with a tight turning radius so it could get around this. We had been buying our chassis from Mack and Peterbilt, which really designed it for long haul trucking and not necessarily for driving around in cul-de-sacs. So that was another thing we wanted to try to do. So as I was driving the team, I kept driving and monitoring these 3 key performance indicators. So how accurate is the AI? Is it making the right decision on what to do in this situation? Since a lot of the stuff is safety critical, we wanted to look at the AI response time. Can it make the right decision, but can it do it quick in enough time to make the right decision to drive the truck or to operate the truck or to keep the operator safe? And the third thing is, are we lowering the total cost of ownership of the truck? That's why people want to buy this, to make sure that they're saving money and improving their business. And everybody's talking about the savings it can get from AI. And we did some calculations, and we believe that these new trucks are about 14% cheaper to drive than the traditional truck. The total cost of ownership is lower. So this is something that's a future opportunity. At the time, this was a few years ago, before all this stuff came up with generative AI and agentic AI. They thought we can have a customer success manager help the fleet manager if they have questions, but a future opportunity would be to use some of this generative AI to so the fleet manager could directly get some advice from an agentic AI, or the customer success manager could talk to them too to help find advice of what to do in these complex situations. So this is this Volterra truck that we developed and sold to Republic Services. And here's a little quick video.
One vehicle is changing the refuse collection landscape. More than a truck, we've engineered a product category all its own. A North American first, purpose-built from an industrial technology leader. Oshkosh fully integrated electric refuse collection vehicle. Integrated, advanced, sustainable. Poised to deliver one of the best driver, technician, and owner experiences imaginable. The vehicle's unique integrated design puts the driver first. From the moment you enter our pass-through cab, you'll notice the low step heights, helping to make a hard day's work a little easier. We've created 38% more space in the cab.
There's more space in the cab because there's no engine in front.
Advanced driver assist systems. You'll enjoy
And the window is back too.
Productive ride, whether you're 4'11" or 6'2". Direct visibility helps drivers see obstacles and minimize.
See the big window now because there's no engine in the
A
front.
McNeilus zero radius vertical liftoff, combined with a tight vehicle turning radius, makes maneuvering cul-de-sacs a walk in the park. Our active safety systems include a 360-degree camera, cross traffic and lane departure areas, object detection, and auto braking, so drivers are aware of their surroundings. The streamlined controls and 15-inch touchscreen minimize distractions and make operation intuitive. Higher pressure monitoring, condition-based maintenance, automated daily checks, and cloud-based telematics keep your vehicles, drivers, and business running smoothly. Yet perhaps the biggest impact we'll make is on the environment. Our electrified drivetrain is built on an e-axle architecture. Combined with our smart battery system, you'll be able to run an all-day route on a single charge with zero emissions. Integrate, advanced, sustainable, raising the bar while lowering the total cost of ownership by up to 14% because it all comes standard. The fully integrated electric refuse collection vehicle, a monumental achievement, and only from Oshkosh.
So that's kind of the function there. So there's a lot of different applications of AI, not just the chat bots that everybody's talking about these days, but there's a lot of stuff you can do with AI and IoT, create smart connected products. So hopefully this kind of showed you other ways that you can apply AI, and hopefully it was educational, informative, fun. So that's what I got. I don't know if you guys have any questions.
This is all battery. The battery's charged and they head out. There's nothing that could interrupt the connectivity and leave them stuck, or if it does, you get the OD message or.
So there is a big bank of batteries. It's not just one battery like your car has today, but there's a whole bank of batteries that are connected together to give you like over 400 volts of DC, and it gives you a full day of charge, and then you come charge it overnight while the driver's sleeping, and then it's ready to go the next day.
What are your challenges?
There was a lot of challenges in this.
I mean, going forward.
Well, one of the things is I think that they could implement agentic AI instead of having a customer success manager. I think that's another way that you could further optimize the business is using that. Yeah.
But you did multiple capabilities implementation. I'm curious to know how long, many sprints or how many, I don't know if you did program increments that it took from the time that an idea came out to the time that actually is put in use.
So I worked on it for about 2 years till we launched it. They had started working on it before I got there, but they were struggling to get some things working, like the connectivity first, and then we did some things to optimize it to try to get it last a full day. But sprints, we were when I work on medical devices, we'd have kind of fixed sprints, like 2-week sprints and stuff like that, or big program increments. This is less regulated industry, less than a class 3 medical device, and we were doing multiple software updates per day as we were doing this to try to develop this quickly and get it done in 2 years.
What's the secret sauce to getting it done quick?
Well, being able to, yeah, one guy's showing us the money. I had a big team. I had my own team, but I had another team in Oshkosh, Wisconsin that were excellent truck engineers that helped me and were kind of on loan to me to do this work. And then we were integrating it in southern Minnesota, all this technology onto the truck and testing it in the parking lot. And being able to do multiple tests per day and multiple software updates per day as we're testing this. We didn't just do 2-week sprints and wait 2 weeks to find out if the test worked. We tested it multiple times a day.
In what states and metropolitan areas across the nation are the Oshkosh trucks currently deployed?
I know they're manufacturing them in Tennessee. I'm not sure what states they're deploying them in. And you can drive this without just being an electric truck with a driver. So you could drive it anywhere in America with a driver. I'm not sure how long it's going to take for all the states to approve autonomous driving. I don't think it's totally approved yet. That's probably still ongoing. If that's what your question is.
Have any of the states currently approved autonomous garbage trucks?
I'm not sure if any of them are approved yet. I don't currently work there.
But they're currently being used in southern Minnesota still to this day?
The company is located in southern Minnesota is where I would go. I'd drive there a few days a week to go work on the trucks firsthand. Sometimes I'd work from home in the Twin Cities, but that's so there's Oshkosh owns several other companies, like McNeilis does the garbage trucks. They also have Pierce, which does the fire trucks, and there's different companies that does their snow plows and their cement mixers and stuff like that. So they're kind of a holding company for other smaller companies. So the headquarters is in Oshkosh, Wisconsin. Dodge Center, Minnesota is where McNeilis is, which is about an hour south of the Twin Cities.
And one last follow-up question. Do these garbage truck drivers need to have a CDL to operate these things?
Yes, I believe they do need that. And yeah, they wouldn't let me drive it. You need a special license to do that. And I was debating getting certified for it, but yeah, I never got certified to be a driver of the truck. So there were certain people on the team that did have the license to drive the truck and test it out.
I'm curious, all the sensor fusion that you had, I think about, the sensors like here in Minnesota, when it's icing or snow or mud or rain. What did you guys have to do to adapt to some of those variable conditions?
Yeah, I have a lot of sensors on my current car, and I wanted to make sure I could turn them off. Because sometimes, like when we get a blizzard in Minnesota, sometimes the sensors can get clogged up with snow and rain and ice. And the sensors basically turn themselves off, and it tells the user that, hey, we can't use autonomy right now because the sensor is clogged or whatever, iced up. Until you clean the ice off the sensor, then we can't use autonomous mode.
So it's doing real-time health assessments
Yep.
of its capability. If it doesn't meet some performance spec, it takes itself offline.
Yep.
Okay.
When testing, what was the most exciting part of testing and what was pain?
Well, it's fun when you start seeing something working, that you've been working on for a while, and you're trying, if, it's not working, and a lot of times we'd get down and, well, let's get under the truck and put some test equipment on. Is the signal getting here? Just that we started with the basic thing of the arm movement. Can you count the number of times the arm moved, and did it show up on the website, And it's like, okay, well, it's not doing that. Okay, well, let's see, is the CAN bus signal sending the right information when the arm lifts to the telematics? Is it getting to the telematics unit? Okay. And then once it gets from the telematics unit, is it getting to the cloud? Okay. And we used we used Hadoop, which is for big data ingestion. Okay. I don't know if I'd use that today, but back then we used Hadoop, and then I'd talk to my Hadoop guy. Did the data get there? Oh, yeah, it's there. Okay. Then, and then we figure out where's it getting stuck until, oh, now it's showing up and it's doing it every time. That's great. And once something gets working it seems something simple like that, but just counting the number of arm things, and did it show up on our website? Yeah, it did, and just, being able to, get the truck self-driving, you know, and being able to have it drive by itself and just watching that do it. I mean, my car does that, but if I take my hands off the wheel too long, it'll tell me, get your hands back on the wheel, you know? But it's kind of cool to see that trucks drive by themselves, you know?
You mentioned you have the three model kind of cars on the city, you have the zero sharing boosting tools on board for identifying how to take out the garbage and setting up while driving.
Yeah, so the question was, there are three different product lines, and what are the differences in the technology between the different product lines? One of the things is different, the front loader and the side loader and the rear loader have different signals. They have different control systems. And so part of the design of the telematics unit is figuring out what signals do we want to collect. And not every truck has the same signals. And so you had to figure out, is it a front loader, a side loader, a rear loader? And then if so, then collect the right signals and send them up to their, and then display them correctly on the website. So that was one of the challenges that we had to deal with because of the different product lines.
And did that cause issues when you were trying to train your autonomous driving?
The autonomous driving, that was not as much of an issue with the different front loaders and side loaders and rear loaders, but there's, you know, there's different size trucks, and there's different things that have to be tuned based on just the dimensions of the truck. The front loaders are the biggest ones of all, and then the rear loaders are the smallest ones of all. So just the dimensions of the truck affect the autonomy and how you do the self-driving.
Curious about the last one you talked about, 14% operating cost savings.
Yep.
Earlier you talked about things like tire pressure sensor and being able to optimize tire pressure. Where did that saving come from? Is that from the wear and tear, or is it from route optimization?
Yeah, so just a truck that, just comparing a truck that we don't do anything to and just monitor versus ones that we monitor and advise how to optimize things. You know, like, okay, if you don't change the tire pressure, or you do change the tire pressure, you will get better gas mileage. Okay, or if you decide you need to tune up the engine, you're getting some misfires, backfires or something, you know, there's different codes that the CAN bus will put on there that tells you that, you know, this diesel engine had a backfire or something, you know, and then other things that you could do to optimize the driving experience. And then just the little time savings of saving a second or two per house with the arm, that adds up throughout the day on, you know, how efficient the route gets done and how much overtime you're paying your driver.
Is there a lifetime value for how long the batteries last on this thing?
That's a good question. I'm not sure how long they last and what the environmental issues are when it's time to replace those. It's I didn't get that far. Let me. Yeah.
So how do you differentiate between like the good material and bad material, the recycling?
Yeah, so there is common things that people throw in the recycling that we tried to be able to identify with the AI, and then we would train the model on these things that are common contaminants that people put in there. So that trash companies told us, here's the most common things that people put in recycling that we don't want. And then we took pictures of that and then trained our AI models to be able to detect those things in the.
So it was mostly visual and it was after it was already in the container, or was it?
Well, that's one of the problems is it's you're already throwing it in the truck and that's when you know, but you've already contaminated things at that time, but you then let the customer know and hopefully you change their behavior in the future. There are other companies that are developing systems that reside in the container, in the dumpster, to try to detect it ahead of time and tell them to get it out or else they're going to get fined. But we were in the business of doing the garbage truck, not the containers.
So is it mostly visual, or I mean, if you use like infrared spectroscopy or
we were using, well, so for this, we were using just visual cameras, but there is another problem that I didn't talk about today that we were using AI that involved both visual camera and thermal cameras. So another thing that I didn't know until I started working there, but it's very common for garbage trucks to catch on fire. Because people throw everything imaginable in the trash. They throw, car batteries in there. You got trash compactors going on, heat and friction. People throw coals from their grill in there, still smoldering a little bit, and before long you got a fire in your trash. And things, you get the trash compactor going on, heat and friction, and you might drive down the road, get some extra air going through the trash and poof. And so we use AI to be able to detect that there is a fire smoldering in the trash and try to alert the driver that this is an issue.
Yeah.
So I didn't know this, but about once a day in America, a garbage truck catches on fire. So, yeah. We can sell those as an option. And also, if they don't buy that, there's been known where the garbage truck catches on fire when it's hot overnight. And then catches the truck next to it on fire, and then all of a sudden a whole bunch of them go up, and it's a big issue for some customers. So let's go way in the back.
How would you describe the amount? When you think about full system, hardware and software involved, how much of it was sort of off the shelf? How much of it were you starting from scratch and building custom for?
So there was the let's see, I think a lot of the stuff was off the shelf. We did work with another company to develop the telematics control unit hardware for us, and we developed the firmware that got downloaded into it. We ran Linux on it with secure boot, and then we would take and load new firmware on top of that. But we would also, I don't know if I said this earlier, but we would blow a fuse after we loaded Linux and after we loaded secure boot and after we loaded the public key. We would blow a fuse so that nobody could change secure boot or change the public key. So hackers couldn't overwrite it with different malicious code. And so that was a way that we tried to ensure, not only did we verify the signature, the authenticity of the firmware that got downloaded was signed by our factory, but we blew a fuse so that nobody could change that public key or the secure boot code. Yeah.
How many empty trash cans does it try to pick up?
That's a joke at the company that companies love to pick up air. And, getting paid to pick up air, if the trash can's empty, they don't care, they still bill the customer for it, they still go to their spot. Now, we were looking at trying to get to a scenario where you could do it on demand. And so instead of you picking up your trash because it's Wednesday, you could pick it up because it's full, but then you would need to coordinate with a smart container and a smart garbage truck to do that scenario. But yeah, right, the paradigm when I worked there was, they would just laugh and say, we love picking up air.
So you don't have like edge cases that pass that, or like.
We talked about it, but that would involve a partnership between the trash container company and garbage truck company, and we didn't get to that while I was working.
For the model, right, you have like this different types of data. Instead of single model, or you have like different models of each other to like your.
Well, there was different AI models, and they, like on the ARM that did the that looked and identified the garbage train, there's a different AI model than the one that looked for rear approaching vehicle, which is a different model than one that looked for the fire inside the truck. I don't know if that answers your question with fire.
Question related to a follow-up question related to an earlier question was, with an average cost savings of about 14% per year, what does that come out to be annual in dollar figures on an annual basis?
It's different for different companies and different trucks.
And it's sort of a semi-related question to another previous question. The front end loading trucks,
Yeah.
what current safeguards are in trucks today or planned for the future to prevent them from picking up cans that have raccoons, cats, even humans inside to prevent, unintended fresh
Yeah,
injuries or
So,
deaths.
so the software that looks for contaminants in there could look for humans. We don't like to talk about that as much. It's not as fun. Levitt topic to talk about, but yes, you can look for humans in there.
This is currently done by humans that are driving the trucks that
Good. The humans would not do that and the AI could do that right now. Because I mean, there, you need a camera in there the way the driver is positioned, they don't really see what's inside the trash can. But the AI can look at that.
well, common to see raccoons and other animals, squirrels and whatnot flying inside.
Yep. Any other questions?
I have one more.
Yeah.
This 14% is impressive.
Okay,
Excellent job.
okay, thanks.
So it's not set for over, I mean, they're expensive, right? Like when they expect 1 year, how many miles or, and then the other side of that is with all these tariffs. Can you keep producing them and selling them?
So
same
these
cost.
trucks are made in America
Yeah.
and sold in America. We did sell some to the Caribbean islands. So I'm not sure if the tariff would be there or not. I haven't, this tariff is all new stuff that everybody's still trying to sort through, but these are trucks that's made in America and mainly sold in America.
Fabulous. Did you use AI to create the parts and manufacturing process?
We did not, but lately I have been using AI to generate software for me, and it's amazing the ability of AI to write software for you. It's getting to the point where you're just integrating the software. You're not really writing the software. You just tell it what kind of platform, what database you're working with, and they'll write you the software, what language you want it written in, and it'll write an amazing piece of software for you really quick. So it's going to change that. We weren't using AI to write our software at the time, but I have used it lately and it's pretty amazing. All right. Any other questions? All right.